In this video, we're going to look at antiderivatives. So in particular, what we're going to do is we are going to start with a derivative, and we're going to try to reverse that process. We're going to try to recover the function that has the specified derivative. So let's jump into some examples, see if we can develop some intuition before we start developing a bunch of rules. All right, so here we have some derivatives that are given. We're going to try to recreate, try to find the original function. So we have f prime of x is 3x squared minus 2x plus 5. So what function has this as a derivative? And so what function has 3x squared as a derivative? Well, 3x squared is the derivative of x cubed, right? What function has negative 2x as a derivative? Well, that is the derivative of the negative of x squared. And 5 is the derivative of 5x. So x cubed minus x squared plus 5x, that has this indicated derivative. What would happen, though, if I just added 2 to this thing? What's the derivative of this new thing? Well, the derivative of 2 is just 0, and all of that is still over there. So this has this as a derivative. What if instead of 2, what if I had 8? Well, the derivative of 8 is still 0, and all the other stuff has the indicated derivative. So in fact, we could add any constant that we want. And so what we will do is we'll write plus c, where c is an arbitrary constant. C can be any constant. Any constant that you want. Perfect. All right, let's look at our second example. Here, our derivative is cosine. So what function has cosine as a derivative? Well, the derivative of sine is cosine. But again, remember, we could add any constant to that. Right? So sine x plus c. Great. And this, again, is that function that has cosine as a derivative. All right, let's look at our next one. Here we have negative 2 over x cubed. Right, so another way that we could write that is negative 2x to the negative 3. So what has negative 2x to the negative 3 as a derivative? So x to the negative 2. Right, so if you were to bring that power down and then subtract 1 from the power, you would get negative 2x to the negative 3. Am I missing anything? Oh yeah, don't forget, we can add any old constant. So that plus c, it's going to need to be there. All right, and what about this last example on this page? 3 secant squared x minus 15x to the 4th. So what function has 3 secant squared x as a derivative? So what function has secant squared as a derivative? Well, secant squared is the derivative of tangent. So 3 tangent x has a derivative that is 3 secant squared x. And this other piece, the x to the 4th, that's going to need to have come from an x to the 5th. If you were to take the derivative of x to the 5th, you would bring that 5 down and subtract 1 from the power. So you'd get 5x to the 5th. But we want to get 15x to the 5th. So we still need to have a 3 right there. And again, don't forget our plus c. We could tack on any constant. Really, all that's doing to the graph is it's shifting it up and down, but it's not changing the slope at any of those x values, right? So those slopes, the derivatives, are staying the same. We're just shifting it up and down. That's what the plus c is doing. All of those things that we just found, those are all called antiderivatives. So those are antiderivatives of a function. So a function f is an antiderivative of little f, right? So a function capital F is an antiderivative of lowercase f on an interval I when the derivative of capital F is lowercase f. Right? That's exactly what we were doing on the previous page. We're just trying to recover the function that has the indicated derivative. Right? So here, let's look at this example. We want to find an antiderivative of 3 sine x minus 4x cubed. So we're going to find, like, its parent function. I don't necessarily like to use that terminology. That's used in like college algebra, where you have like a parent graph and then you shift it left, right, up, and down. So we're just trying to find the antiderivative. So what function has 3 sine x as a derivative? Well, sine x is pretty close to the derivative of cosine x. But remember, the derivative of cosine x is negative sine x. So we need to have a negative here. And this 4x cubed is going to have come from x to the 4th. And don't forget plus c. This thing right here that we have found, this is a general antiderivative. We don't have any specific values. If we were to find a specific antiderivative, you might have something like f of x equals negative 3 cosine x minus x to the 4th. Maybe like plus 7. This is saying we have a very specific function. But we would need more information in order to be able to determine that's the specific function we're trying to find. And eventually we'll get there. But that's a specific antiderivative. All right. In our next video, we will look more at antiderivatives, and we will talk about the process of integration. We will see you there.